Yeah, the culmination of the student track, everybody. Before anything else, a quick round of applause for our students who've all done amazing work over today. Awesome, awesome. I always say this to kick off the final bit of the student presentation. An important thing to realize is, I don't know, I want to start with this. This is honestly my favorite bit of the entire DevDays experience is the student presentation. It's really cool to see people come in and like, with a week of effort. And I know you guys had really no time to prepare for this. And I mean, the amount of work that you guys got done in the short time you had, honestly, is incredible. It's I don't know. I mean, to me, I just think it's a really good sort of bit of proof that FHIR is an approachable standard and is something that you can pick up without, you know, needing to do 8 years of PhD just to figure out how the thing works. So I think that's really cool. You know, the experience we gained from sort of seeing you guys go through this goes back into the standard. And every year we sort of look at what was easy for you, but also what was hard for you. And honestly, all of the experiences you guys have, the challenges that you reported during your presentations, like all of that information does feed back and hopefully will make next year's students have an even easier time doing it. Who knows? We will see. Well, I guess we should probably announce the winner. It was, of course, difficult. All of the teams did super awesome stuff. Okay, so we've got a winner. We didn't even discuss this, but I want to give one little honorable mention. I don't think we've had this before. We had a high school team here this year, which I thought was really cool. So I think an honorable mention to them just for basically coming in and figuring out without even any programming experience how to get something uploaded. I thought that was super cool. Yeah, let's do a little applause for that. Hopefully we'll see a bit more of that even in the future. So, the winners, and I'm standing blocking the prize actually. So the winners of the competition, of course, get this lovely, this trophy, which I hadn't lifted. It's really heavy. Huh. I thought that was made of plastic, but I don't think it is. Cool. As well as one of these LED lights. You may have seen one of these things shining above the Firely booth when you first came in. They're pretty cool looking, actually. So, drum roll, please. The winners of the 2018 Amsterdam Student Track Competition is FHIR for Legacy Devices, the team from the University of Upper Austria. Congratulations, guys. Totally. So these guys are just going to get themselves set up. We did not warn them that they were going to win, so now they have to scramble to get ready to do another presentation. Yep, here comes the legacy devices.
So we still have to boot up the program? Test? Yeah. So we still have to boot up the program, but we start with the presentation, and then later we can have a live demo. So the original assignment was to build an application, but we had a different idea. We wanted to use FHIR for legacy systems because a lot of the time medical institutions have the problem they use old legacy systems without IP interface who are very expensive and can't be replaced so easy, but they have no way to automatically connect data to a file server, for example. This is especially the case in with vets and other medical institutions. Our solution was to use a communication server, a Raspberry or Banana Pi, to connect to the legacy system, so little laboratory device or different device. And this is usually with a serial interface over a USB port. The Banana Pi then stores the information, the data, the measurements, and it can send the data to a file server after it has transformed the data to valid resource, for example, an observation. Do you want? Okay.
So this emulator that we built, oh, excuse me 1 second. Okay, so this Fire server here, I'm sorry. I'm sorry, I just have to get in because I had to start all the programs in the background. So here we have the Raspberry Pi and that handles all the data. It gets sent the serial data from a laboratory device, and this laboratory device can be something, excuse me, okay. We're just gonna go with the next slide. I'm sorry. Okay, so that's our architecture. We have our laboratory device on the right side here. It has a non-specified way of communicating. That's a huge problem for a lot of people because there are still a lot of laboratory devices, old laboratory devices out there that can't be replaced because they cost too much, especially for veterinarians and small doctors. And for this case, we built this program. The serial data gets, first of all, is transmitted to our Raspberry Pi and is then parsed. And in the second state, it's converted to an internal format. And if we don't know the patient that corresponds to the data that's transmitted, we are saving it in our MongoDB database. And the next step that's going to happen is if the patient is known, it gets transmitted to the Fire server, and first it gets converted to a Fire resource.
If it is transferred to the Fire server successfully, the data is deleted from the Banana Pi, so it no longer exists there.
Okay. So what you can also do is afterwards, if you view the web interface, we're going to show it to you afterwards in the live demo. But first, we're going to show you our device. That's an emulator device that we built especially for this case. We didn't want to bring a full laboratory system or a legacy laboratory device, and therefore we built this Arduino-based transmission device. It reads data from an SD card in a special file format, and it sends it over to the Raspberry Pi via USB. So this is the file format that we actually used. The first is how many iterations it will send, and the second line is just delay between those iterations. And all this other stuff is just a basic example of what a laboratory device can or could be sending. In this case, we have two values that are transmitted, CCRP and T4. And this gets then translated to the internal format that you can see here.
Yes. The internal format only saves the relevant data. So in this case, the person ID, which is also a valid Fire resource ID for a patient, test name of the kind of test we are doing, date time, and in this case, the two values who are saved in a list. And the whole thing is a JSON file variable. So it then gets transformed into a valid Fire resource. In this case, it's two Fire resources because we have two values. They have a code to the display a human can read. They have a patient who is under the attribute subject. And also as a link, we have the attribute related, because we never know in which way these observations can be related. For example, if it is blood pressure data, it is important that systole and diastole are somehow related. And as we are not sure what kind of relationship it is, we just say it is a has-member relationship. Yeah, that is our website. One can see. This is the first page where you can see how many.
This is our status page, or the page that everybody can view. Here you can see all the devices that are currently logged in or actually saved. Here we only have one device. It's called Arduino. And you can see in the graph how many transmitted or not correctly transmitted measurements you have in the database. So this is our status page, but we're going to show you this in the live demo now. I hope we're ready now. Okay.
Okay. So I will now go to the website. So I have to reload it. Just a moment.
This takes some time usually. No. That's a MongoDB error.
Okay, then I will show the slides. Yeah, so, okay, this is the page you see after you've logged in, because you have to log in. There are the users, test data and devices, which is only one, the Arduino. These are all the test data that we have stored because the person ID is not valid. So we don't want to remove them or delete them because maybe they are important. And there is an option that we can remake or rewrite patient ID and resend it. So in this case, we selected one of these test cases, and we changed the person ID to a valid patient ID. And if you click on Save, it will be sent, and an observation will be created. And we use different test servers. One of them is the DevDays 2.3, and if the creation was successful, there will be a log just at the top of the page which says observation created with the observation. And as we tried to check if the observation really was created, so we tried in Postman with the ID, and it exists. It's working? Okay. So hopefully.
So in this first step, it loads all the saved devices. As you can see here, log loading devices. It initializes the parsers to parse the data that's incoming. And we can take a look at the web interface now, hopefully. Okay, that looks promising. Sign into Data Hub. Okay, here you go. That's the admin page actually. If you want to view the status page, that takes a while probably. Yes, just one more second. Here you go. So we have currently 0 saved test data because it's pretty much empty. When you log in, you see this page, and here you have test data and devices. At the moment, we have one registered device. It's also registered in Fire. And here you can see the serial connection that it actually uses on the Raspberry Pi and stuff like that. Everything on the baud rate is used to parse the data from that is received from legacy laboratory devices.
Yeah, because the serial interface only gives us document, so we interpret it as a string, and we have to parse it with regex at the moment. And so we have these fields, and every of these fields defines attribute we want to use in the internal data.
And that's pretty much the only way that's possible to interface so many devices, because we wanted a single solution for a bunch of different devices and not one that's only where you're only able to use one single device. So we wanted to have a general solution for pretty much any old or legacy device. So we can test one thing. We can use our emulator and send some data. It's pretty hard to show it off because I would need a camera, but I don't have one. You just have to trust me on this. I'm now sending a few examples. Just reload the page one. Yeah. Yep. Here you can see I've sent 2 different laboratory test data, and they could not be sent because the ID was not correctly input. So, okay. I think it's for... I hope that's the correct ID because otherwise it wouldn't send. Okay. Just reload, yeah. And it sent it to the Fire server and also deleted the entry because it's no longer needed because we already handled the problem. Yeah, just we take a look at the command line. You can see, you here can see the whole log of the transaction from MongoDB to the Fire server.
I just have to look. So the first thing we see is if I scroll way up, oh, okay, it's way up, is normally it displays the internal data, but then it shows the JSON format which is created. Okay, here we have an example. Here you can see observation created with the new ID. And yeah, the code system, what I showed you earlier, and the value and the unit. Just have to look. No, so here we have a single observation, so there is no... oh yeah, there's a related one. So you see, here's a log observation with new related attribute because we have more than one observation. Here's the related member with a different observation. Yeah.
Well, I think that was it. Maybe we just talk about one more thing. Maybe lessons learned, yeah. So we have a few things that we learned during this process and during our work here. For example, that's not always that Keystone, the framework we used, was a bit hard to use for this specific task, and we didn't really research it beforehand. And at the middle of the work, we came to the conclusion that it wasn't the best choice, actually. Well.
On my part, I learned that you have to structure your code from the beginning, especially if you work in teams, because is it on? Yeah. Especially if you work in teams, because if you don't comment, you don't know what the other person did, and in the end, it gets kind of messy. As well as you have to create backups because maybe you have a general overhaul and then something little doesn't work, and you have nothing left from the from the system before that. So just save it, and yeah, just save it beforehand. Yeah, we tested it with 2 servers. We did that in a hackathon. And plans for the future are that to make the site more user-friendly, because at the moment it's you have to be a programmer to understand it. Yeah, and we have to load the data site manually, but we should do it automatically in the future.
That's probably just one line of code, but we still don't know where to put it because we would have to hack Keystone to make it possible.
Okay.
Thank you very much. Any questions?
Good afternoon, everyone. The lights is bright no matter where I stand. We are the judges for the startup track, and we had a very, like I say, a very difficult task. There were 5 pitches, and they all were very inspiring. And yeah, we had to, in the end, make a choice. For us, we had 3 dimensions we took in consideration for deciding which startup should win. First of all, the value proposition. How crisp and clear is it? Just do we know what the customer has to say yes to? How is Fire incorporated? And next of all, in a way, is new technology also embraced in the solution? After a long consideration, deliberation, and it was a very hard and complex decision, we chose Liven as winners of the startup track. Yes. Would like to congratulations, guys.
Yeah, thank you. Yes. Good.
Yes. Now, my fellow judges, could you elaborate a little on our decision?
Handing the hot potato over, huh? Yes. Well, it was, as you said, difficult because there were a lot of, incomparable things. But what we liked about your presentation was, as you said, the clear value proposition, and it's immediately clear the problem you solve, and also the business approach, where it's a kind of Trojan horse approach that once you're in with Fire, be it with the old paper interface, you've aligned yourself in the hospital, you can take it from there. So we like that. We like that approach, and the fact that the proposition is immediately clear in the presentation.
Yeah, the market, the go-to-market of an add-on and connecting to existing software was compelling. The support of PDF technologies. There's large databases of existing PDFs that this could be applicable to, and AI, having a bit of the optical character recognition was great. So, and to see that all tied in, your data model was also really clear. And as another vendor, that gave us, oh, this is how we could start connecting. And so.
Yep. And I would just like to say that it was very hard for us to pick a startup because when we were initially creating the startup track, I even had the difficulty of defining what is a startup. And of course, we would get participants in all sorts of the startup stage, and that was, of course, going to be uneven, and we did not include the amount of funding or the stages that the startup was at. We tried to ignore it because it's impossible to get a level playing field in that. So the thing that I was really interested in as well was their entry point. It is very easy to integrate with existing technologies. It's very easy to send something to a PDF and to a printer. So it's a very clever idea. And it also has a pathway towards the future, is that once you're in with this, you can expand your network, you can expand your Fire endpoints, and you can get everybody connected. So it's an idea that can really take off. So congratulations.
We'd love to accept. We'd like to actually thank the jury for their consideration here and actually for being invited. We've been thinking about coming to, we just said it actually in the previous session, but we stumbled on Fire when the first time somebody asked us to integrate with our systems and take advantage of our functionality. We started, and this is kind of a little bit of history so that everybody gets empowered and understands how the power of Fire is, that we started with a proprietary API. When people asked us to integrate with our API, we put a Fire gateway in front of it, and then we realized how great that is, and then we switched our data model to be in Fire native. So we're kind of an embodiment of how all this energy that we feel in the community. This is the first time we're attending actually the Fire DevDays. We feel that we're going to be here every time. We're never going to miss another one of these events. Not because we won, I mean, irrespective of that, but it's great. We'd love to do the pitch for the people who haven't attended before. I mean the pitch, the explanation, so that people maybe have another bit of background on this. And what we didn't get to into the pitch, and I wanted to touch on it, is that fundamentally we use many Fire resources, but we're actually, this was our V1 that we're already deploying in production, and we're actually expanding, but we have other things that are coming that allow us to interoperate with existing systems, where we can bring EHRs that we have been exchanged between medical professionals back into these systems that are field closed. So we're building gateways into the other direction, from Fire into HS7 V2 and all these things. So the value is in hybrid worlds, right? It's in the transition. You have to live with existing legacy systems. That was the previous pitch of the student track. We can't live in a greenfield world that doesn't exist. We have to create value as a community also for the existing people who have data, and we just have to find ways to create that value and just get in. And once from there, the rest is history. So, cool. Thank you.
Congratulations.
All right. Do you want